Welcome to the channel of the magnetic wizard of the 123 and the atomic galaxy of the Trion Triangles. The following video shows the orbital patterns of planet T4 and the shadows that it casts upon planet T3. The information from NASA, Astropixels, and the Max Planck Institute's Astro Apps are used to show examples and comparisons of the Earth-Moon system and the planets T4 and T3 system. T3 is the home planet of the Tritonians. Okay, so in the following videos, you're going to need to know some information about what is being shown. So I'm going to give you a brief on it. It's not going to be very detailed information. If you want more detail on these Saros cycles, you can find out that from NASA's website. So anyway, these are all Saros cycles. Right here, each one of these. This right here is the Saros cycle number 117, number 122, 127. Those are all the Saros cycles numbers. Each one of these cycles runs for, they have different time durations, but they average about 1,300 years. You can see this one right here starts in the year 792, June 24th, and runs to the year 2054, the month of August, day 03. So there's somewhere between 38 and 42 of these. I say somewhere between there because it changes. They don't have the same amount or same number of eclipses or Saros cycles. Some of them arrive, some of them disappear, as you can see with their start dates and end dates. This one right here starts in 991, ends in 2235. So another one in here is this one starts in 624 and ends in 2904. So after these come to their end date, they do not appear again. So another Saros starts up somewhere in between or after these disappear. So anyway, there's that. There's also the partials. These are the partials. This is the totals, and these are hybrids. This changes as it moves through time. So it's starting off as a partial, moves into a total, moves into what they call a hybrid, these H's, and then moves to an annular and continues on until it gets back to a partial and then disappears. These are the magnitudes over here. Magnitude is the amount that it is covering the sun in its eclipse. So this one right here being a partial, you can see the small amount of the coverage on over the sun, and it's partial, and then by the time it gets to a total, it's covered the sun completely right here. So this right here is the Tritonian father, mother, child, which is the equivalent of the total eclipse, the annular eclipse, and the partial eclipse, being father, mother, child is what they call it. And there's always only 38 of them, not 39, 40, 41, or 42. There's always 38, no more and no less. This one right here, well, let's go back to the one here. This is the 0, 1, and all the way back to the 38. You can see that there's only 38. Each one of these right there is the father. So 01 F father or 01 total eclipse. 02 child, which is the partial eclipse. And these over here are the Tritinian shadow wheel. Shadow wheel 66. There's a total of 66 spots, segments that these eclipses arrive at. And this is all running in odd numbers. And then the next one on the 2, 1 is odd, 2 runs in all evens. So each one of these is skipping on the odd. The evens is skipping the odd numbers. So there are 19 odds and 19 even. And as you can see right here, this one is starts off, or not starts off, but is right here, goes from 65 to 01. And it's going to go skipping again all the even numbers until it gets to 65 again right here, and then go back to 01. And it doesn't do it again on what they have for Earth anyway. On Triton 3, this continues on as near as anybody knows for eternity. It never stops. The pattern remains the same indefinitely. So every single one of these does that. On here on Earth, they begin and then they end. On Triton 3, nobody knows how long ago they began, and as near as anybody knows, they never end. They are forever. So I think that's about it for these. Yeah. Okay. So moving on to this, which you will see on the video too. I believe we showed you this first, showing this first on the video. These are from Triton 3 star dates that have been converted over to Earth dates right here. And some places they were typed in here incorrectly or somehow converted incorrectly. So there's places where there's some places that were left out apparently, and because these are first run on these, we didn't have time to make a corrected version of all these. They just were printed, they were typed in and printed, and then this is what we got for now. So what you're looking at here is just to place a date that we started back in here on this one, 1603. We did go back one more date back in here, and if one goes back further than this, you run into some trouble with the year of 1582, which will be explained a little bit later. That has to do with a date change, a skip in time of 10 days that occurred over in, I believe it was Britain, England. So we don't really go back beyond this date in anything that we work with because of that little skip in time there. So we also run these all the way up here. There's 49 total. You see 48 in here, but we do have 49 of them because we did add one back here. So there's a 49th one. And this is on this particular one on 01F. It runs in green. The green right here, you see these green lines right here underlining each one of these dates. What this is the Tritinian father shadow is equal to or comparable to a total eclipse. So all these right here will be father shadows in green, and all of them will be total eclipses. But on Triton 3, these are all, every single one of these dates is green, meaning they're all father shadows. And they also all exist. They run all the way to here and all the way as far as you could ever see. Doesn't stop being a father shadow. And so anyway, but on this one right here, same one, 01F, or Saros cycle 117, it starts off, as you can see again, as a partial, goes into an annular, which is right here in 1946, should be. Let's take a look. Where am I looking at? Go this way. 1946, partial, and then goes to a total, which is again the father, and that's why it is marked green in 1928, because they are comparable in their magnitude. Partial runs yellow, meaning that it does exist. It still there still has an eclipse running there until you get to 2054, and which is the last one in yellow, because that is the last one on the Saros cycle. No more eclipses exist on the 01F after 2054. The next one that does exist on Triton 3 would be the equivalent, the conversion date to 2072 here on Earth. And that's why all the rest of these are red, because they don't exist on the Saros cycle. So, okay, there's that. Let's see what it's going to tell you about this. Let's go to a simpler one to look at over here. These over here. Oops. All these numbers over here are the Triton shadow wheel numbers. Right over here. These over here, these dates over here are, they are the Tritonian date, which is converted over to, the conversion goes to this date here. This right here is, you can see 2235, 2235.3747. That narrows it down or pinpoints the within approximately the hour of the year of 2235, 2235.23, or I'm sorry, 2235.3747 will equate to May 17th at whatever hour that eclipse happened. So what else? Yeah, as it says up here, all dates shown are conversions from Triton 3 star dates to Earth star dates. So these are all the conversions. This is this one and number 27 have the full conversions on them. We just didn't get to completing all these. It's been a lot of work and a lot of time, but as you can see the 27 has all the conversions on them. And up here, these are just something that I was working on, and we wrote these on here, but these are the moon counts from 5 to 6 for the previous eclipse, or 38, from 38 to 01, FMC 38 to FMC 01 has has 5 moons from one eclipse to the next. And the 6 up here is the 0, 1 over to the 0, 2 is a total of 6 moons from one eclipse to the next. And that's what all these numbers up here are. This one right here is the previous eclipse moon count, and the one over here on to the right is the following moon count to the next eclipse moving forward. And yeah, so you can see some little scratch out in places and things. You can see right in here where this is just was from being typed in incorrectly. This this eclipse or shadow uh, arrives on December 4th, not 14th, and this is the same thing happening here. So these are just little typed in incorrectly, and then found that they were not correct on there. It just hasn't been corrected on these with the new sheet. The corrections are still just scratched out on here. So there are places where that happens on there. I just thought I'd explain what that is, why that is. Simple little errors that were found in what was being written down on here or typed in here, and then found that they were incorrect. So there's a few places like that on there. So okay, I think that's it.